Okay, hello everyone. Let us continue the third part of this today's class. Okay, we have said that this is the integration, the inner integration in equation 1. That is, this integration is equal to this equation. Okay, so next. Okay, this is equal to, okay, you can see that here is a row bar I and here is a row bar I. So these two row bar I's can be cancelled. So it is equal to 1 over 1 plus row bar I times beta over sine squared theta. So because this one can be rewritten as sine squared theta over sine squared theta. So this equation is equal to 1 over sine squared theta plus rho bar I beta over sine squared theta. And this is equal to, okay, the reciprocal of the denominator. Okay, that is sine squared theta over sine squared theta plus rho bar I times beta. Okay. Okay, like this. Okay, perfect. Okay, finally substituting equation 3. Okay, this equation into equation 1. Okay, equation 1 is this equation. Okay, let me copy this and paste here. Okay, we get, okay, P bar B is equal to 2 alpha over pi times integration 0 to pi over 2, and the product I is equal to 1 to nd. Okay, and we replace the inner integration, okay, by the equation 3. Okay, like this. Okay, like this, and the theta. Okay, and this should be 4. Okay. Okay, so I finish. So we finished the solution of this problem. Okay, do you have any questions? Okay, if you do not have any questions, let us go back to the slides. Okay, so we can get the last line of the equation 1.11. Okay, since GD is defined in the limit as the signal to noise ratio, becomes large, we are interested in examining the expression for P bar B when the average SNR values on each of the diversity paths approach infinity. That is, as rho bar I approaches infinity, where I is equal to 1 to ND. Okay, here GD is the diversity gain, and the meaning of examining is 检查、细查、诊查、查问、盘问、检查、调查。And ND is the diversity order. For simplicity, we assume that the average signal-to-noise ratio on each diversity channel is the same and denote rho bar I is equal to rho bar for all I. Therefore, limit rho bar approaches infinity, P bar B of rho bar is equal to limit rho bar approaches infinity 2 alpha over pi times the integration from 0 to pi over 2, and sine squared theta over sine squared theta plus beta rho bar to the power of ND d theta. How do we obtain this term? Please return to equation 1.11. Because we now let rho bar I is equal to rho bar for all I, so this term can be replaced by rho bar, and the product from I is equal to 1 to ND. Now in this term we do not have any term which is related to I, so we can replace this product by the power of ND. So we have this term to the power of ND. After some computation, we can find that this equation is equal to 2 alpha over pi times beta to the power of ND and times the integration from 0 to pi over 2 sine to the power of 2ND of theta d theta times rho bar to the power of minus ND. This is equation 1.12. So how can we get this equation? Please see the handout. Page 137, problem 1. Derive the second line of equation 1.12. Answer. Please see the blackboard. Because we do not, I do not blackboard here, so I use the Microsoft Word instead. Let me close this file first. This is chapter 1, page 135, problem 1. So let me open a new document in Microsoft Word. So now this is chapter 1 and page 137. And problem 1. Derive the second line of equation 1.12. Okay, so here it is the solution. The first line of equation 1.12 is, okay, let me copy the first line, okay, of equation 1.12 to here. Okay, good. Okay, is this equation. Okay, when row bar approaches, oh, okay, I miss an infinity. Okay, because beta is a positive constant. Okay, we can back to the slides to see what is the value of beta. Okay, on page 128, beta is equal to 1 or 1 second. So beta is a positive constant. Okay, so beta times row bar also approaches. Oh, I missed the infinity again. Okay, infinity. Okay, then beta times row bar is much greater than sine squared theta. Okay, and we can replace sine square of theta plus beta times row bar by beta times row bar. Okay, then okay, equation 1 is equal to okay, is equal to okay 2 alpha over pi times integration from 0 to pi over 2, and we delete this term. Okay, sine squared theta. Okay, then sine squared theta over beta row bar to the power of nd d theta. Okay, then the alpha 2 alpha over pi is remain the same, and we can see that beta rho bar is a constant. Okay, so we can move it out of the integration. Okay, after moving out of the integration, it is equal to 1 over beta times rho bar. And please do not forget the power nd. Okay, and the integration becomes the integration from 0 to pi over 2 sine to the power of 2nd of theta d theta. Okay, so it is equal to 2 alpha over pi and times beta to the power of nd. And then we move the rho bar to the power of nd to the end of this equation. So it becomes the rho bar to the power of minus nd. And this integration remains the same. Okay, so let us align at the equality and add the equation number here. Okay, so we have finished the solution here. Okay, so any questions? Okay, if you do not have any questions, let us go back to the slides and return to page 137. Okay, so finally we can get this equation. We note that the equation above has the same form as equation 1.3. Okay, let us see equation 1.3. Okay, in equation 1.3, it follows that in the linear region, we can express the bit error probability mathematically as follows. PB is equal to zeta times GC times EB over N null bar. to the power of minus GD. Okay, where zeta is a constant that depends on the type of modulation. GC is a constant, sometimes called the coding gain of the system. The bar over NB over N null denotes the mean. Okay, so let us go back to the page 138. Okay, so for zeta is equal to 1, where GC, the coding gain, and GD, the diversity gain, have the following forms. Okay, we can see that GC is equal to 2 alpha over pi times beta to the power of ND times the integration from 0 to pi over 2 sine to the power of 2ND of theta d theta and to the power of minus 1 over GD, and GD is equal to ND. Okay, how do we get these two equations? Okay, let us see the handout. Okay, page 138, problem 1, derive equations 1.13 and 1.14. Okay, the solution is setting zeta be equal to 1. Then equation 1.3 becomes PB is equal to GC times EB over N null bar to the power of minus GD. Okay, for notation simplicity, we use rho bar to represent EB over N null bar. Then equation 11, okay, this equation can be rewritten as PB is equal to GC times rho bar to the power of minus GD. Okay, from equation 1.12, we know that, okay, this equation, okay, limit rho bar approaches infinity, P bar B of rho bar is equal to 2 alpha over pi times beta to the power of ND and times the integration from 0 to pi over 2 sine to the power of 2ND of theta d theta times rho bar to the power of minus ND. Okay, comparing equations 12 and 13, we find. Okay, let us compare the equation of 12 and 13. Okay, you can find that here is the rho bar here. Okay, and it's minus GD. This is the minus ND. So this term in the bracket is equal to GC to the power of minus GD. Okay, so GC to the power of minus GD is equal to this equation. And rho bar to the power of minus GD is equal to rho bar to the power of minus ND. So then equation 14 can be rewritten as, okay, this is equation 14. And we take the power of minus 1 over GD on the both sides of equation 14. Then we can have the left hand side of equation 14 becomes GC, and the right hand side of equation 14 will have the power of minus 1 over GD. Okay, and from equation 15, it is obvious that, okay, since we have this equation, then we have GD is equal to ND, okay, which completes our solution. Okay, let us go back to slides. Okay, it is 25 minutes. Let us take a break.